Hi, my name is Nicholas Nowakowski. I'm a member of the Sorensen Clinic team at the University of Utah, and my senior project is to develop a double talk detection algorithm. Well, my first milestone is just to develop the MATLAB code that implements this double talk detection algorithm. This algorithm should output a 1 when double talk is present and a 0 when no double talk is present. Well, double talk is when there's two speakers talking at the same time. They're on a conference call or something, and they're both talking at the same time. Well, this whole system involves a echo cancellation filter, and when one speaker is just talking, the echo cancellation filter is able to operate at the normal way. But when two speakers are talking, it assumes that that is just one speech signal, and it'll mess with the coefficients and cause them to diverge, which is why we need to detect when two speakers are talking, and we can tell the echo cancellation algorithm to not change the coefficients while there's two speakers, which will allow it to function normally. How is this done? Well, first off, we have to take in two signals. We're going to call the near end speech signal D and the far end speech signal Y. Y is the signal that's coming out of the speaker, and D is what's going into the microphone. And we're going to measure the power of both of these signals, which is essentially just the signal squared. And we want to compare the power of the Y signal to the power of the D signal. When double talk is present, the power of the Y signal should be less than the power of the D signal, which will make the ratio less than 1. And when the ratio is less than 1, double talk is present. But when no double talk is present, these signals should be essentially the same, taking into account noise, but essentially they should be about the same, which would make the ratio essentially 1, which means no double talk is present, and we should output a 0. These are my simulations in MATLAB. This simulation I only used add and double talk. There was no noise on the original signal, so when double talk was present, it's clearly less than 1. When double talk is present, it's pretty much equal to 1, which gives me my flat lines and shows that it's operating correctly. But this is when no noise is present in the single signal. This simulation, as you can see, there is noise present even when there's no double talk present. You can tell because it's a little bit above and below 1, but I created a threshold which shows which these ranges are within the threshold, and when there is double talk present, it's less than 1, and this shows that the algorithm works with a certain amount of noise present. What is the use for double talk? Well, as I mentioned before, when double talk is present and both speakers are talking, the echo cancellation filter assumes that it's just one speech signal and it can't properly cancel out the echo, and it makes the coefficients diverge to an infinite number. So we want to flag them and then tell the echo cancellation filter that there is double talk present and do not change your coefficients, and this will allow it to operate normally when double talk is present. So, concluding on this, we need to detect when two speakers are talking at the same time. This is done by comparing the powers of the far end signal and the near end signal, and using this to decide is double talk present or is it not. And this will communicate the presence of double talk to the filter, and that will allow it to make a decision based on whether double talk is present or not. And if double talk is present, the filter should not change its coefficients, or else it will diverge. Now let's look at the MATLAB code that I used to implement those simulations. So these first couple lines are just kind of constants and pre-allocating my arrays to make it faster. And then we're going to take our input. We're going to take our input signal, and then we're going to filter it. And we're going to take this filtered signal here, and we're taking the power, which is the mean of a certain amount of n. N is a input that's taken, so the user can choose the average amount of inputs they want to, the number of inputs they want to average for the power, and then we get both powers here. This is the power y, this is the power d. Then we can pair them, and then we're going to create a matrix. This is a check matrix. So we're gonna take the absolute value of the ratio, and we're going to subtract 1 to make it easier, so that it should be less than the threshold, and the threshold should be close to 0. So in a perfect world, if double talk is not present, then the ratio should be 0 because we're subtracting 1. We create this array, and this variable k is given by the user, which allows the user to choose the number of checks they want. So we're going to check for, or let's say k is 5, so we're going to check the first 5 signals, and if they're all within that threshold, which means, so if they're all enough where double talk is not detected, then we're going to say that double talk is not present. And then, so if all of those values in this vector are less than the threshold, we're going to call it, say check is 1. And then if check is 1, we're going to say that double talk is equal to 0, which means double talk is not present, and we're going to update the filter and reset check to 0. This is just, we take the first certain amount of samples because the filter's it's getting to its value, it's canceling out the echo, so we want to say that double talk is not present for the first certain amount of values, so it doesn't just assume double talk is present right off the bat. Here is the simulations I created. This allowed me to simulate it. I created an x variable, just an array of random numbers used as my speech signal, and then we convolved it to get my D signal, which is my far end signal. And then this M allowed me, I used it to create a certain amount, a percentage of noise. I took my double talk and I made it an array, a set of random values the same size as D, and then I set double talk equal to, in this case, it's 20% of the double talk, so that is just noise. I don't want it. It shouldn't detect double talk when at these values, because this is just, I wanted to create a certain amount of noise, and I added them together, and then I got my, whether double talk is present and my ratio, and then I plotted them to see how the ratio was compared to whether double talking, and when, to see if my program was working correctly, and I got it to work correctly. So this is what I was hoping to complete for Milestone 1, and now we're on to Milestone 2, and we're finished implementing this in MATLAB for now. That is it. This is my video for my Milestone 1 double talk detection algorithm. Thank you for watching.